Okay, in today's video, I am going to go through the difference between exothermic and endothermic reactions. And before that, I do that, I'd like to go through a couple of the important terms I think you should be familiar with. First one is energy. Energy is the ability to do work. You can think about it, if you're going to do some work, you're going to need some energy. So energy is often defined as the ability to do work. It has the capital symbol capital E, and it's measured in the metric unit joule. And enthalpy and heat are also measured in the unit joule, named after James Prescott Joule, and has the symbol capital J. Enthalpy. Enthalpy is a measure of the total energy that is within a system. So usually we don't actually measure the total energy, but we measure the change in energy, and the change in energy would be therefore delta H. Enthalpy has the symbol capital H. The change in energy is delta H. Well, if the energy is changing, then heat must be flowing in or out of the system. Heat has the symbol Q, and we often talk about the change in energy. And heat is the transfer of energy or the flow of energy from one area to another, and it always flows from high temperature to low temperature. It does not rise. A lot of people think, oh, heat rises. Well, it does sometimes, but it always flows from high temperature to low temperature. And the change in enthalpy and the change in heat will be the same as long as the process takes place at constant pressure. Okay, so energy, enthalpy, and heat have different meanings, and you should be aware of what those meanings are. Okay, let's go through specifically what the difference is between exothermic and endothermic. All right, exothermic, as the name says, it's exo, the heat is exiting, it's exothermic, and because it's exiting, I like to tell my students that it will feel hot. So if you are doing, or when you do, an exothermic reaction or an exothermic process takes place, it will feel hot. And normally we don't do reactions in our hands because it's dangerous, but we can measure the change in temperature with a thermometer and the temperature will go up. And sometimes you can actually, maybe in a Ziploc bag or something, you can do a reaction and you can feel that heat coming out of the reaction. For example, when you put calcium chloride and dissolve calcium chloride in water, that's an endothermic process. And it feels hot, and it feels hot because the reaction is releasing energy. So energy is being released. So it releases energy, and because it's releasing energy, the change in enthalpy, or I'm going to put the change in energy, delta Q, for the reaction is going to be negative. All right, so this is negative. Now, a lot of people think, oh, hot heat coming out, it must be plus, but it's negative because the heat is coming out of the reaction, and this is the delta Q for the reaction, not the delta Q for your hands. You feel it. Okay, so the delta Q for the reaction is negative because it's releasing or it's losing energy. And because it's losing energy, the products in the reaction, the products have less energy than the reactants. Okay, so the products have less energy, and then we often draw this simple graph. You see the simple graph drawn for this type of reaction, and it looks like this. On the y-axis we have energy, on the x-axis we have time, and because it starts with high energy, then we need a little activation energy to get it going, and then it releases energy. The products have less energy, so we put a P down here for this is the products, and we put an R up here for this is the reactants. And you can see that reactants have more energy than the products. Okay, so I think that's the basics of what an endothermic reaction is. Excuse me, exothermic reaction. Now let's look, of course, at endothermic, and you should notice that they're basically the opposite of each other. Endo means in, like we have endoskeletons, it's inside of our bodies, and therefore the energy is going to be absorbed, and then because it's absorbing energy, if you were to do this reaction in your hands, which of course we don't do that again, it would feel cold. So this would be a cold reaction, and sometimes you can do this in my class. Sometimes we'll put barium hydroxide an ammonium nitrate in a Ziploc bag, and you can feel the reaction getting cold because it's absorbing energy, and it's absorbing that energy from your hand, so it feels cold because it's absorbing energy. Now you can also do that reaction in a calorimeter, and you would see the temperature go down as you measure the change in heat or the change in temperature of the water. So this one will absorb energy. Okay, and because the reaction is absorbing energy, the delta Q, the change in energy for the reaction, is going to be positive. This type of reaction, endothermic reaction, has a positive delta Q, when the delta H would also be positive. And because it's absorbing energy, the products are going to have more energy than the reactants. And therefore, the energy diagram for this reaction will look something like this. Okay, we're going to start with the products down here. Again, this is energy, and this is time, reaction time. And the products will have more energy. As the reaction goes along, it will absorb energy. Okay, it will absorb energy, and then the reactants, excuse me. So these are the reactants, and this is the energy of the products. So you can see as the reaction progresses, the reaction absorbs energy, and the products have more energy than the reactants. Okay, so I think those are the basics of exothermic and endothermic reactions. They're basically opposite of each other. One feels hot, one feels cold. One releases energy, exothermic, and one absorbs energy, endothermic. Okay, so I hope that was helpful, and thank you very much.